Greetings, and welcome to this episode in the series of videos on working with remote sensing with ArcGIS Pro. This series is brought to you by AmericaView in partnership with Virginia Tech, the Virginia Cooperative Extension, and Virginia View. I'm Cherie Aukland, and I'll be your guide. This video tutorial series builds on ongoing and previous collaborations and contributions provided by the USDA NIFA through the ADVANCE project, the National Science Foundation, through the GeoTED UAS project, the Ohio State University, and the Virginia Space Grant Consortium. This video series is associated with the Remote Sensing with ArcGIS Pro 2nd edition book. We will use Landsat 9 imagery in this series, and we'll also begin with Chapter 10. Links to resources for this video series, including free access to the textbook and to the videos for Chapters 1 through 9, are available in the video description below. Remotely sensed imagery is useful in detecting changes in features on the surface of the Earth, such as land use and land cover. Imagery is required from two different dates and usually from the same sensor. Change detection aims to identify changes in the spectral properties of specific features in the two images. The time interval can be as short as a few days, for example, to detect the impact of a natural disaster, a few months to assess growth in large agricultural fields, or a few years to several years to monitor changes in forest extent. These analyses are called change detection. Please see your text for a detailed discussion on change detection analysis, including what kind of information changing spectral properties of images can provide, identifying and selecting suitable pairs of images, and pre- and post-classification techniques. This chapter relies on knowledge gained from chapters 11 and 13 through 19. We'll use several processes from those chapters. We will introduce a simple procedure of pre-classification change detection to evaluate landscape changes from drought and wildland fire. We'll use one band from each of two Landsat 8 images acquired over southwestern Colorado on two different dates, and calculate differences in pixel values between these images to evaluate changes. Here's our scenario. On June 1, 2018, a fire started in the San Juan National Forest of southwest Colorado. This fire was named the 416 fire. As of June 21, 2018, the fire had destroyed over 34,000 acres of forest and was only 35% contained. The extensive nature of the fire and the inability to contain it was directly related to recent drought conditions in Colorado. NOAA had deemed this region to be in an exceptional drought. A typical annual snowfall for this region is approximately 71 inches. However, in the 2017-2018 winter season, snowfall was 65% less than average. Local snowpack, typically present in June, was gone by 2018. So let's download our images. Using the techniques of Chapter 11 and 13, download two Landsat 8 images from Path 35, Row 34 from June 15, 2017 and June 18, 2018. Since Earth Explorer provides the option to select which bands to download, you can choose to download only Band 5 for each date. These are the two Landsat 8 images as viewed in Earth Explorer. Notice the difference in snowpack between the June 15, 2017 image and the June 18, 2018 image. Also notice the cloud cover, which we couldn't avoid during this time period. So why did we choose just Band 5? As you can see from the table, Band 5 emphasizes biomass content and supports the identification of shorelines. A fire will significantly lower biomass. Also, drought changes water body size, thus changing the shoreline, and snow is just frozen water, all pertinent to our study. We begin with a new map project, and I've added the Band 5 images to the map with the 2018 image as the top layer in contents. We'll first use the change detection wizard. Let's select both layers in contents, then on the Imagery tab, in the Analysis group, go to Change Detection and open the Change Detection wizard. We're using the pixel value change method, which should be the default change setting. If we drop this down, categorical change would be used if you were completing a post-classification change detection operation. And time series change would be used, for example, if you calculate the change in NDVI over a growing season. We're calculating the difference between the from raster, I'll choose the 2017 image, and to raster the 2018 image. I'm happy with the other settings on this page, so let's go to the next page in the wizard. We want absolute for the difference type. The from and to raster bands show 1-band_1 since our analysis uses single bands. We're using the default for cell size type and extent type. Here we see the preview, if we want to, which processes the change detection but creates a temporary preview of the image. Let's go to the next page. Here we want to compute statistics and histogram. In the Contents pane, we now see the new image and the statistics and histogram for this new image in the Change Detection Wizard pane. I'm going to save here. And I'm going to go ahead and uncheck and collapse this preview because we're not going to use it. In fact, I'll just go ahead and drag it down to the bottom. This default symbology, red, is an increase, green, a decrease, and yellow, right in the middle, means little or no change. The most notable change is in the clouds. The clouds are shown as red, one of the extremes in the change. The 2018 image has clouds, and the 2017 image was cloud-free, which we can see here. Here's the 2018 image, and here's the 2017 image. When performing change detection, we recommend eliminating clouds as much as possible. Change detection is used to monitor changes in the surface of the Earth, and obviously clouds interfere with that process. The second noticeable change is in snow cover. Let's use the swipe tool to compare the images. The top image is our 2018 image. Here is our 2017 image. You can see in the 2017 image, there was snow present in the mountains, but no snow present in the 2018 image as I swipe up. 2017, 2018. Now let's take a look at the area that experienced the wildfire. I'm going to zoom to this area right here. The lack of snow cover from the drought and the lack of vegetation from the fire both show a huge change in spectral values. Here we see green represented as a decrease in the vegetation, which if we look at the two images and swipe through, we can see that there was vegetation present in the 2017 image and that there is no vegetation present in the 2018 image, and the preview mask shows that as a decrease in green. Now let's turn off the change detection image and zoom in to two lakes just to the east of the 416 wildfire. I'm going to turn off my swipe tool. I right-clicked and locate these two lakes just to the east. Zoom a little bit. I turn my swipe tool back on. As we swipe through, we're looking at the 2017 image. And as I swipe up, we can see in the 2018 image, there are parts of the lake that are missing. It's a little bit difficult to see, actually, in a grayscale image, right? But if we turn change detection back on, the changes we see in red along the edges of the lakes are another of the extremes for the change in spectral values. The lakes in the 2018 image are smaller than the earlier 2017 image. Band 5 is often used to discern shorelines, and you can see from the red that shorelines experienced a significant change. Further, the shallow water in 2018 exposed sediment deposits concealed below the surface in 2017, as indicated by the green you see here within the lakes. You may need to employ image enhancement techniques to better view these changes. And if you're unsure what the original features represent when looking at this change detection image, you may want to add a natural color or false color composite image to the map project. Now let's look at a different tool for change detection. Recall from prior chapters, ArcGIS Pro provides many geoprocessing tools, and we're going to use the Image Analyst tool from the geoprocessing pane. We'll populate with the 2018 image on top, and then the 2017 image, and we'll run the tool. You may get a default grayscale image. You can easily just go to symbology and change the symbology for this. But our results do appear to be different looking at the range of values and contents. But are the individual pixels different? Let's zoom in, say, to the burned area and find an individual pixel. This one, for example. Let's turn off my swipe mode. And we'll choose this image right in the middle, minus 1379. And if we turn that off and go to the preview mask, it's minus 1379. This concludes the change detection process. Again, ArcGIS Pro provides many options for this processing, including the two methods discussed here and using the raster calculator. The bands selected for the change detection process will depend on the project's goal and the features preferred for evaluating the change. This chapter addressed change detection only, and note these images of southwestern Colorado will not be used in any other chapter. So let's head to chapter 21.